Statistical thermodynamics is actually a branch which deals with determining macroscopic properties using the microscopic informations. Okay, what does it mean? Listen, see, we have macroscopic substances, okay, or macroscopic properties. What are macroscopic properties? Properties associated with the bulk substance. Properties associated with the bulk substance is called macroscopic properties. Okay, say for example, if you take a gas in a cylinder, then the pressure of the gas is a macroscopic property. Similarly, internal energy, enthalpy, entropy, everything comes under macroscopic properties. Okay, so to study the macroscopic properties, okay, we have a branch called classical thermodynamics. Classical thermodynamics. Okay, so to study macroscopic properties of substance, bulk substance, we have a branch of science called classical thermodynamics, or we can also say a Newtonian mechanics. Right, using Newtonian mechanics, we can study macroscopic properties. But what I am trying to give here is, we are going to study thermodynamic properties. So that's why I'm using the word classical thermodynamics here, right? So here the macroscopic properties that I try to mean are thermodynamic properties like enthalpy, free energy, entropy, like that. Okay, so to study the macroscopic properties of bulk substance, we have a branch called classical thermodynamics. Similarly, to study microscopic properties, okay, to study microscopic properties, properties associated with the atoms, properties of atoms, properties of molecules, right, etc. That is just a microscopic, right? You cannot see those particles, right? Atoms are very tiny particle, you know very well. Molecules are very, very tiny particles. So you cannot see these particles through naked eye. So we can call them as microscopic particles. Okay, the properties associated with the microscopic particles are called microscopic properties. See, to study microscopic properties of substances or microscopic particles, we have a branch of science called quantum mechanics. Okay, we have a branch of science called quantum mechanics. So, to study macroscopic properties, very specifically thermodynamic properties of bulk substances, we have a branch called classical thermodynamics. Similarly, to study microscopic properties, okay, microscopic properties means properties associated with the atoms, molecules, even ions, etc. Okay, those properties can be studied using quantum mechanics. Now, listen, we know very well, suppose if I take a gas in a container, okay, suppose I'll take some gas in a container, I have some gas here, and I'll keep a pressure gauge here, pressure gauge. So the pressure gauge will give me what is the pressure of the gas. Okay, say for example, the pressure of this gas is say 3 atmospheres. Okay, now this 3 atmosphere pressure is the pressure of the whole gas, whole, or we can say the pressure exerted by all the molecules, we can say. But we know very well this total pressure 3 atmosphere, okay, is actually exerted by each and every molecule present in the gas, right? See what I'm trying to say. See, every molecule in the gas, okay, contribute some amount to the total pressure. Okay, what we measure using the pressure gauge is actually a bulk property, macroscopic property. So the 3 atmosphere pressure is the macroscopic property of the gas, right? But we know very well this pressure, okay, is actually each and every molecule in the gas, will contribute some amount to the total pressure. Okay, but I don't want to say that all the particles will contribute equal amount. No, I'm not saying like that. Observe carefully. This 3 atmosphere pressure is actually due to all the molecules present in the gas. Okay, and we know very well every molecule in the gas will contribute some amount to the total pressure. Every molecule. But what I'm not saying that all molecules exert same amount of pressure. No, some molecule may contribute in larger extent. Some molecule may contribute in smaller extent, like that. Some molecule may not contribute at all. Okay, at a given time. But so what this tells me that the macroscopic property is definitely depends upon the microscopic particles present in the bulk substance. See, this gas is the bulk substance. This gas consists of molecules. These molecules are microscopic substance or microscopic particles. So pressure, total pressure is the property of the gas. But we know very well each and every molecule in the gas definitely contributes to some extent to the total pressure. Definitely contribute, right? So by doing some analysis or by doing some calculation, is it possible to calculate this total pressure by taking some property of each and every molecule present in the gas? See what I'm saying? Is it possible to calculate this total pressure by taking some molecular properties? You take some molecular properties and add the molecular properties of all the molecules. Is it possible to get this pressure? Listen, it's very, very important to predict the total pressure. Okay, we can take linear momentum or change in momentum of the particle, each and every particle, but it is very, very, very tough task, right, to track all the particles, right, at each and every second. See, some molecule, say I have some molecule A here and another molecule B here. This molecule A will give some pressure at a particular time, but the same molecule A will give a different pressure, will exert a different pressure, right, at a different time. So it is very, very difficult to track each and every molecule in all the time. It's very, very difficult because the gas consists of huge number of molecules, right? The gas consists of huge number of molecules. So it is very, very, very difficult to track each and every molecule, right, continuously. It's not possible. So, but it is very clear that the total pressure or macroscopic properties definitely depends on microscopic properties present in the bulk substance. Okay, right. So to handle this, to study the macroscopic properties using microscopic informations, we need a special branch. We need a special technique. That special branch of science is what we call as statistical thermodynamics. So what we are going to do in statistical thermodynamics, we are going to determine thermodynamic properties, okay, using the quantum mechanical informations of the molecules or atoms. Excuse me, sir, are you able to follow this? Hello?
Okay, sir.
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
See, the properties associated with are the thermodynamic properties. Thermodynamic properties of substances can be determined or can be calculated, okay, using quantum mechanical informations about the microscopic particles present in the substance. See, suppose in this gas you may have atoms or you may have molecules, right? So take the atoms or molecules and find their quantum mechanical information. Using the quantum mechanical information, it is possible to calculate the classical the thermodynamic properties. Okay, so for this we require a special branch of science called statistical thermodynamics. I'll put shortly ST. So what is statistical thermodynamics? Statistical thermodynamics is a branch of science, okay, that is that connects the macroscopic properties, or that connects the classical thermodynamics and the quantum mechanics. We can say like that. I repeat, statistical thermodynamics is a branch of science that connects classical thermodynamics and the quantum mechanics. Right? What specific information that I like to say here? Thermodynamic properties can be calculated. You can calculate, theoretically you can calculate the thermodynamic properties using quantum mechanical informations of the atoms or molecules present in the bulk substance. Right? Sir, any doubt here?
No, sir.
No, sir.
Okay. Yeah. Right. Now, yeah. So listen, macroscopic properties. Macroscopic properties, also called for our study. Okay, we are going to take thermodynamic properties. Not all macroscopic properties, only thermodynamic properties. So thermodynamic properties of bulk substances, right? Macroscopic properties of bulk substances can be calculated using microscopic properties, also called quantum mechanical informations. See, here I am giving you microscopic properties. Actually, what I'm trying to mean here is these microscopic properties are quantum mechanical properties, right? Of the microscopic particles, right? Present in the bulk substance. See, the bulk substance, you know very well, each and every bulk substance is made up of atoms or molecules only. If you take water is made up of many water molecules, right? Similarly, if you take sodium chloride crystal, it is made up of sodium ions and chloride ions. So every bulk substance, right, is made up of microscopic particles, right? Now, the property associated with the bulk substance called macroscopic properties, and properties associated with the microscopic particles called microscopic properties, right? Then this can be obtained, microscopic properties can be obtained from quantum mechanics. Using quantum mechanics, we can find the microscopic properties. The macroscopic properties can be obtained. See, I told you very specifically what macroscopic property I'm going to handle. I'm going to take only thermodynamic properties. Okay, I'm not going to take all macroscopic properties here. I'm going to consider only thermodynamic properties. You know very well, thermodynamic properties are macroscopic properties, right? These macroscopic properties can be obtained from classical thermodynamics. I'll put shortly as CT, classical thermodynamics, right? So using classical thermodynamics, we can determine macroscopic properties of this bulk substance. Now listen, we have this information, macroscopic informations. We also have microscopic informations. Now what we want is how to connect these two. How to connect these two. That is how to determine macroscopic properties using the microscopic properties. How to do that? That part of science, right, or that part of problem was taken care of by the branch of science, a new branch of science called statistical thermodynamics. So, நம்ம statistical thermodynamics என்ன பண்ண போறோம்னா, we are going to determine macroscopic properties using microscopic properties. Or we can say in another word, in another manner, that statistical thermodynamics connect classical thermodynamics and quantum mechanics. Okay, yeah. So this is the idea. Now, to understand statistical thermodynamics, first of all, we must know some of the terms that we are using here. So what are the terms? Number one, macro state. Macro state. Number two, micro state. Number three, thermodynamic probability. Thermodynamic probability. Number four, most probable macro state. Most probable macro state. Okay. Then we should know what is meant by Stirling's formula. Okay, these are all some main terms that we are using in statistical thermodynamics. We will try to learn these first. We'll try to understand these terms first. Then I'll introduce how to proceed with the statistical thermodynamics. Okay, yeah. So the first term is macro state. What is meant by macro state of a substance? Macro state. Okay, what is meant by macro state? Listen, macro state can also be called as configuration. Macro state can also be called as distribution. Right? They are all equivalent terms. Macro state, configuration, distribution, these are all equivalent terms. Now what is meant by macro state? Listen, macro state is nothing but macro state. Okay, I'll use the symbol M. M means macro state. Macro state is a specification. Macro state is a specification of number of particles. See,